So let's talk about the goodness of fit test. In this type of hypothesis test, you're going to determine if the data fits a particular distribution or not. So one way that we can look at it is, say I want to know the results of a binomial distribution. And I know you haven't really heard binomial before, but binomial means that you have two outcomes. Think of it like you toss a coin and you have a head or a tail, or you want to know, do people say a yes-no question, how many people said yes, how many people said no. You use a chi-square test to see if the data that you have, the observed data, fits what you expect it to be. So when you do this, you can write null and alternative hypothesis to be if it fits the proportion or not. So the goodness of fit test, the website will do it for you, but I just want you to kind of understand a little bit of what's going on. So if you see this up here, the goodness of fit test statistic is that the sum of all the observed minus the expected squared over the expected. So you're probably looking at it like, I'm not really understanding what's going on. When we look at the example 1, you'll see what was going on. So again, what am I doing? I'm comparing the observed to the expected, squaring it, and then I'm dividing over the expected for all of the categories. You'll never want to do this by hand because there's all software for you to do this. Now, if your expected or observed is under 5, you'll need to run a different test than this. It's called a Fisher's test. It behaves very similar, but it takes into account for really low data.